December in 2010, and this was where my trip was, okay, in 2010. And so from here on out, we have 86 strings, and we don't have to put any more in. So IceCube in action now. So this is now a particle going through IceCube. You're going to see a lot of these pictures. This is the Cherenkov light, that blue light, remember? And when the blue light hits one of these phototubes, you get a ball. The size of the ball tells you how much light hit it, and the color of the ball tells you the time that it got hit. Okay, so here's Cherenkov radiation hitting the phototubes and them recording. Of course, all this data goes up through the cables and out to the satellite. So there are the things we want to look for are astrophysical neutrinos, but there's a lot of neutrinos and muons that come from cosmic rays hitting the atmosphere. And that's a real big problem for us because we're not very interested in those, but there's lots of them, okay? So we call that background. So that's the background, and this is what we want to see, the direct neutrinos coming from the object. This background comes from protons hitting the atmosphere and making neutrinos and muons. So we have background neutrinos, muons and neutrinos. I hope this one works. Okay, oops, sorry. We'll get it. Okay, so these are the DOMs again, but these are the thousands of muons that are coming through and hitting this, and that was one big giant bundle of muons that came through. And so this is all uninteresting data that we have to filter out using the computers. So atmospheric muons, well, the cosmic muons, this is in a year we get about 10 of them, okay? But we get all of this number of muons and neutrinos. So we have to work really hard. These, there's 3,000 per second, and these, they're about 1 every 6 minutes. And so those are the background, and we have to get rid of them. Another thing I have to tell you about is there's two different types of events that we see. One is when a muon goes through the array, we see something like this. It's a long, we call it a track, okay? So that's a muon track. Other types of things like electron neutrinos or other types of things make a round thing which we call a cascade, okay? And this is all Cherenkov light again. So this is one of the first events. It's an 89 TeV. We're going for 1,000 TeV, so this is pretty good, okay? We can look at this. Remember, the radius is how many photons hit it, and the time is, the earliest is red and the latest is purple, okay? So this is up, this is coming through the Earth. So if you look at this, this is the earliest time and this is the latest time, and so this is an upgoing muon, okay? And so it was probably produced by a neutrino. And then we had a big surprise. After about a year of running, this event occurred, and I wish I could speed this up, but I can't. This actually happens in a few microseconds, but this video is a lot slower. Okay, so anyway, we see this is a cascade event. We saw it a cascade event. It had a lot of photons hitting, so it was very high energy. This is the event, okay, that I just showed you. This is the size of it, okay? This is the University of Wisconsin. That's one of the centers for IceCube, and it covers a large part of that. It's about a quarter the size of Central Park, okay? So that's probably something better we know. So we saw this event. It was 1 PeV. That's 1,000 of these TeV units. And there was another one that was 1.1 PeV. So this was a surprise. This is what we wanted to see, but we were worried we wouldn't see it. There could be no neutrinos like that. So anyway, the first event was called Ernie. Okay. The second event was called Bert. And we found another event that was 2 PeV that we called Big Bird. Okay. So these events are too high energy to be these atmospheric background. There's no atmospheric particles accompanying them. But the big thing is we need to find more if we're going to do something with this. And so how can we find more? So a very smart graduate student figured it out, okay? He said, oh, we can use the outside of the detector. So this is the detector, you know that thing down there, kilometer by kilometer by kilometer. If we only look for events in this region, we can use the outer part as what we call a veto. If we see any light in the veto, it means that something's coming in. It's not a neutrino. A neutrino would come in and it would interact, and you would see nothing here, okay? So this was a big breakthrough, and when we did this, lo and behold, we got 28 events, okay? And you can see all of their names. Miss Piggy's down here. And here's the other 14, okay? Okay, so this is Bert and Ernie. These are the 28 events. And so we published a science article. This was a big thing, November. And then we had a Big Bird came along too. And then this was awarded the Breakthrough of the Year in 2013 for the science and for the experimental accomplishments of building IceCube. So the neutrino sky was another surprise for us, okay? So after running a few more years, we had 54